Hello everyone! Thank you so much for the amazing discussion in our last video. So many of you asked brilliant questions about tools, especially the Octotester versus the trusty Multimeter. Let me clear this up. Neither is a replacement for the other. In fact, they're better as a team. Now, I'll be honest, if you're on a tight budget, a Multimeter is the MVP. But here's the cool part. The Octotester is the hero for quick, specific jobs on electronic circuit boards your Multimeter can't handle alone. And no, this isn't a component tester. Just to show you, a component tester is really exceptional at testing components out of circuits. So here I've got a transistor. I'm just going to place it into our component tester, and this tells us that it's an NPN transistor, which is perfect for testing out of circuit components. Today I'll be showing you the differences between the Octotester and the Multimeter, but at the end of the video you'll know exactly when to grab your Octotester or grab your Multimeter, and why every electronic geek needs both. Ready? Let's go. To demonstrate, we have a switch mode power supply. Now I'm going to test this with the Octotester and the Multimeter, and we'll quickly get to the differences between both. We'll be doing some fault finding on this switch mode power supply. First of all, we're going to give this a quick visual inspection, and straight away you can tell this is faulty because of the large burnt area on the main side. Straight away you might be thinking to yourself, is it even worth repairing? And it's probably not worth repairing at this stage because of the extensive damage. Just for sake of exercise, we'll do some checks. What we are going to do is we're going to follow the main side of the circuits through each of the components. So the main socket is nicely indicated as live, ground and neutral. So if we look on the live side, we actually have a fuse directly in series. So if we test across this, we actually get an open circuit, and the reason behind that is obviously because the fuse is blown in half. So looking onwards, we have our 4-bridge rectifier, which is made of 4 diodes used to convert our AC signal to a DC signal. So what we can do is we can actually test across each of these diodes. So these diodes are labeled D1, D2, D3, D4. So going across D1, we can see that D1 is a healthy diode trace. As you can see on the Octotester, we're getting the activation voltage trace showing. So I'm just going to go across each of my diodes and test each one. We've got some short diodes here which indicate that they are faulty. Another useful tip here is we can actually check which tracks are still intact, and we can do this by basically checking which tracks are short to each other. And as we can see, this track here is not short, so this indicates that it's broken. Next, we'll follow this circuit along, and after the 4-bridge rectifier, what we have is the capacitor, and this capacitor is actually 22 microfarads. When I go across it, we get the nice oval trace, just as we expect. The Octotester picks up a nice clean trace on this capacitor because I've removed the transformer. So after the capacitor, we do have the transformer. So I've taken this out of circuits and just testing across the windings. We want a low resistance across the windings. I'm actually struggling to see a short between some of these windings, which might be the connection with my probes, or it could be the windings are failing inside the transformer, or are failed along with other components. After the transformer, we have the switching MOSFET. Again, it's personal preference, but you can take out the transformer. Here's a diagram of the MOSFET, and our pins are gate, drain and source. So going across our drain and source, we see a short circuit, which is expected, and going across our gate and drain and gate and source, we see a resistance, and this is picked up from the rest of the circuitry. This is why you need to have some know-how when testing in circuits, because you end up picking up a lot of different traces. So I'm just going to test some of these resistors to make sure we're not getting any shorts or open circuits. These resistors are giving us a nice diagonal line. I'm happy with that. So moving on, I'm just going to test some of this low voltage side componentry. I don't expect this to be faulty, so just testing some of these diodes, and we get a nice diode trace. Again, it matters, the connection of the probes matters. And these capacitors are actually 470 microfarads, which our Octotester won't pick up because of the range. And this capacitor here gives us a weird trace, and that is a combination of components. So what you've got there is a resistor, the ceramic capacitor, and the transistor, which gives us the diode trace, and all that's combined to give us that weird looking trace there. Okay, so we're going to do the same with the multimeter. I'm going to take out this transformer just for ease. So again, we'll start from the same live pin and we'll follow it to the fuse. We're testing across the fuse. We're getting an open circuit, obviously, because the fuse is blown. Then we move on to our 4-bridge rectifier, just testing diodes in diodes mode. Struggling to get a connection here, so this might be faulty. A good 0.6 volts. Then it's also hard to get a good connection with these probes. It takes a lot of pressing down, a lot of pressure. I'm happy there with these diodes that they've got the 2 faulty ones as indicated by our Octotester. Alright, so moving on, let's go on to the capacitor. So in capacitance mode, let's test across this 22 microfarad capacitor, and we do indeed get 21.45 microfarads, which is what we expect, which is good. Then we move on to transformers. Let's just test across these windings in continuity mode. And it is quite difficult to get a connection between some of these, which again might be because the transformer's failing or has failed and is open circuit. Okay, so let's just do the same checks on the switching MOSFET. So we're just going to check between drain and source, which should be a short, and we're going to check between gate and source, which picks up a resistance, and that's from the other components there. We're just going to test across some of these resistors and see what sort of values we get. If they're in the ballpark, as long as we don't get any open circuits, we're happy. Okay, so then we can move on to the low power side and just test some of these diodes and capacitors. So just testing across this this capacitor here. I actually couldn't pick anything up there. But yeah, other than that, I'm pretty happy with this low power side, because it seems that it's just the main side that was damaged here. So wrapping up, the multimeter, that's your best friend. It's always got your back, versatile, and it's ready for anything. But the Octotester, that's your secret weapon. It's quick, clever, and easier to understand. Remember, great tools don't compete. They complete each other. Which one do you reach for first? Let me know in the comments. I read every single one. Thanks for joining us today. Stay curious, and I'll see you in the next one.